So starting with a basic concept of atom. So as the basic concept, what is the basic concept of the atom? The basic concept is that the central part of an atom, which we call a nucleus, and inside the nucleus we have subatomic particles such as protons and neutrons. Around the nucleus, electrons moving a specific region, which we call shell or orbit. Example, if we have two protons are there inside the nucleus. So if we have two protons which are inside the nucleus, as we know, like charges repel each other. So what happens? These two protons try to repel each other, try to push each other out, but the nucleus is holding or combining or keeping them together inside the specific region. So means there is a very strong force because like charges repel each other. So as like charges repel each other, these two protons should go out or go away from each other and move outside the nucleus, but still they remain inside the nucleus and nucleus is holding them together. So how the nucleus is holding them together? By applying a force, and that force we call that as strong nuclear force. So basically strong nuclear force is a force which is binding the particles which are inside the nucleus, and we call that as strong nuclear force, or the force which is binding these nucleons. Outside the nucleus, because electron is revolving around the nucleus, so nucleus is attracting this electron as well. And but compared to these proton and electron, this electron is compared to this proton and neutron, this electron experience a weak force, and the force which is attract the nucleus is applying on the electron, what we call that as, we call that as a weak nuclear force. So basically there are two types of forces which exist within an atom. One is a strong nuclear force, which is a short range, and it is acting on the particles which are inside the nucleus. And another one is a long range, but which is a weak force, and that is called weak nuclear force. So within an atom, we have strong nuclear force and we have weak nuclear force. So in terms of basic particles, in terms of fundamental or basic particle, what we do, we divide the particle into two classes. Some of the particle which experience strong nuclear force, and some of the particle experience weak nuclear force. So the particles which experience strong nuclear force, these particles are simply known as quarks, and the particle which experience weak nuclear force are known as leptons. So basically, there are two fundamental particles. One is called lepton, another one is called quark. What is a quark? As you have proton and neutron, so in reality, proton is not the fundamental particle. Proton also consists of small particles, and the particle which make this proton, like this proton is there, this proton is not a fundamental particle. This proton actually consists of small particles, and these particles are known as quarks. Later in the chapter, we'll discuss in detail the concept of the quark. So proton itself is not a fundamental particle. It is made up of further smaller particles. The types of the quark in detail we'll discuss, but this is just introductory concept. So proton is not a fundamental. It is also consists of tiny particles such as quarks. Same thing, neutron is also not a fundamental. What neutron consists of? The neutron itself consists of tiny particles known as quarks. But what is electron? Electron is a fundamental particle. Electron is we cannot break this electron into further smaller particle. So what is electron? Actually, electron is a lepton. Why electron is a lepton? You can see the particle which experience weak nuclear force, we call them as lepton. The particle which experience strong nuclear force, we call them as quarks. Or quark is a very small particle. When combination of the quarks are there, we use a specific term, we call them as hadrons. So hadrons are the particles which experience strong nuclear force. That's why this proton and neutron are also classified as hadron. So the term hadron means the particle will experience strong nuclear force. The term lepton means that the particle will experience weak nuclear force. Is it clear that this is introduction of the topic, that you will learn about different types of particles in this chapter? So first thing, the concept of a strong and a weak nuclear force. Strong nuclear force, the force which exists, which is a short range force, and this force acts between the quarks and the particle which normally experience these strong nuclear force, we call them as hadron. Same thing, there are particles which experience weak nuclear force, we call them as lepton. Any doubt in this basic introduction?
No.
Then what happened? For every particle, there is antiparticle. Whenever there is a particle, there is antiparticle as well. What does it mean, particle and antiparticle? Like you have electron as a particle, and we represent electron by E, and the sign we show as a negative. What is the charge of electron? The charge of electron is minus 1.6 into 10 to the power minus 19 coulombs. What is the mass of electron? It's 9.11 exponent minus 31. That is the mass of electron. For what is the antiparticle of electron? Antiparticle of electron means it will have the same mass, which is 9.11 into 10 to the power minus 31 kg. It will have the same magnitude of the charge, but the only difference, antiparticle or opposite particle, if electron is a negative, then this antiparticle of electron is having a same charge but positive. And the name of this antiparticle of electron, that is called positron, not proton. It is called positron. Why proton is not an antiparticle of electron? Because proton have the same charge, same magnitude of the charge, but it does not have same mass. When you say proton, proton is a massive particle as compared to, so a proton we represent by P symbol. When we write the charge, it's 1.6 into 10 to the power minus 31 kg. Sorry, when we write the charge, by mistake here, the charge is 1.6 exponent minus 19 coulomb. But when we write the mass is 1.67 into 10 to the power minus 31 kilogram. Minus 27 kilogram, not 31. So you can see the mass of proton is not same as mass of electron. So proton is not the antiparticle of electron. There is antiparticle of electron which is called positron. So what is the difference between particle and its antiparticle? The only difference between them is the nature of the charge. They all have the same, the particle and antiparticle have same mass. They have the same magnitude of the charge, but the nature of the charge is opposite. And what happened when the particle, because if you have electron which is negative and you have positron which is positive, so unlike charges attract each other, so when particle and antiparticle mix, combine with each other, what they will do, they will release energy, and this process is called annihilation. When the particle and antiparticle combine together, why they are combined together? Because they have opposite charge, so they attract towards each other. As they attract towards each other, the particle and antiparticle will their mass will change into energy, and the Einstein formula, which was E is equals to mc square, will give us how much energy is released when the particle and antiparticle mix with each other. This, what is m here? This is a sum of the masses of the two particle, m1 plus m2. So we'll add the mass, and c is the speed of a light, which is 3 exponent 8. So when we'll substitute the sum of the mass and speed of light square, what we will get? We will get energy which is released when particle and antiparticle will mix with each other. And this process is called annihilation. But why you don't observe any annihilation here on Earth? Reason for that, because on Earth we don't find antiparticles, we have particles. In outer space, we find particles and antiparticle both. That is why in outer space, there are interaction of the particles, like annihilation occur. But on Earth, you have only particles. You have electron, you don't have positron. Interaction, the particle interaction or particle accelerators can be used to produce different particles. But naturally, we don't have antiparticle. That's why we don't observe this annihilation. So this can be a theoretical source of energy. Practically, it will be difficult to control an amount of energy release. But theoretically, if we have a particle and antiparticle, what we can do, we can allow them to combine with each other, and they release energy, and that energy can be used to drive different mechanisms. So this mechanism, maybe some of you have seen that movie Star Trek. So that's a very old movie, but they use the same concept, that when particle and antiparticle will mix with each other, that produce energy, and that energy can be used to drive the spaceship. So this is all introduction. Now start with the main topic. So we have particles and we have antiparticles. So what is the characteristic of the particle and antiparticle? They have the same mass. They have opposite charge, opposite spin to the original one. Like example, If one is rotating clockwise, another one rotate anti-clockwise. Opposite value of this part, baryon number, lepton number, and stranges, we'll discuss later because that's related to the other topics. So example, the first antiparticle which was discovered was anti-electron, and this anti-electron is also known as positron, and it is denoted by E with a plus charge. So if we have proton, antiparticle of proton is called antiproton. How we represent? If we want to write a symbol for antiparticle, so we will use a bar. If proton is denoted by P, then antiproton is denoted by P bar. If electron is denoted by E, then anti-electron or positron is denoted by E bar. Like here is a particle electron neutrino. This is not electron. This is another particle electron neutrino. So antiparticle of this will be anti-electron neutrino. If the sign of electron neutrino is mu, this is the Greek alphabet mu and subscript E, then anti-electron neutrino will be bar with a mu E. So this is a particle and this is anti-electron neutrino or antiparticle. So what will be the difference between them? They will have the similarity, they will have the same mass, they will have same magnitude of the charge, but opposite sign, and they have opposite spin to the original. Like what does it mean? It means if one is rotating clockwise, another one rotate anti-clockwise. And they have opposite values of baryon number, lepton number, and strangeness number. So I want you to copy the first part, particle and antiparticle. Only the shaded part you will copy. And write these two examples as well. Then particle interaction. As a particle interact, like particle and antiparticle, with first annihilation and then pair production, because opposite of annihilation is a pair production. So what is a pair annihilation? Pair annihilation or annihilation. So example, when you have a particle and you have its antiparticle, so example particle, we have electron and its antiparticle is anti-electron. So what happened? The two particles attracted, move towards each other, and as they move towards each other, they combine with each other. As a result of this combination, what it produces? It produces energy. And in what form this energy is released? This energy is released in a form of packet or bundle, and what we call this as? We call that as photon. So when particle and antiparticle combine with each other, their mass change into energy, and we use the formula Einstein mass energy equation, which is E is equals to mc square. And to find the energy of the photon which is released, so to find the energy of a photon which is released, what we can do? We can use this formula E is equals to mc square, where m is the mass and c is the speed of the light. And what is m? M is the total mass of these particles which are interacting here. But what happened? Instead of producing one photon, they produce two photons. Why they produce two photons? Because if I say, what is the initial momentum? The sum of the momentum before they collide. The initial momentum is zero. Why the initial momentum is zero? Because if the momentum of this particle is mv, the momentum of this particle is also mv. They are moving with the same speed, they have same mass. But if they are moving in opposite direction, so what is the original momentum? So if the original momentum is zero, so the final momentum should also be zero. So if one photon was released, then it means there is a resultant momentum. That is why when this interaction will occur, instead of releasing one photon, how many photons are released? It releases two photons. So we will use the formula E is equals to mc square, and we will find how much energy is released, and that energy will be divided by 2 to get the energy of one photon, because this E is the total energy which is released in this interaction. Example, if I say after calculation, I get energy as 30 joules. So if the energy released is 30 joules, the total energy, what is the mass of, what is the energy of each photon? So energy of each photon will be half of what is released. So that will be equal to 15 joules. And sometime, what is the SI unit of the mass? The SI unit of the mass is kg. But sometime, instead of giving mass in kilogram, they give the mass in mega electron volt per c square, or giga electron volt per c square. These are also unit of the mass. The SI unit is kilogram, but other unit can, in terms of particle, mass of the particle can be mega electron volt per c square or giga electron volt per c square. How you can have a mass in this unit? Like you have the formula E is equals to mc square. E is the energy. SI unit of energy is joule, but it can be electron volt. As we know, 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if, for example, instead of energy is given in joules, energy was given in mega electron volt or giga electron volt. So what will be the unit of energy? It will be mega electron volt. And this is mass, and c is the speed of a light square. So this speed of light square will go there in division. So what you will get answer? You will get answer in mega electron volt per c square. What is the significance? Why we prefer this mega electron volt per c square or giga electron volt per c square instead of kilogram? Because this will make our calculation easy. Like example, if I say mass of particle is 9 mega electron volt per c square. So if this, what is the advantage of this using this unit? So if mass of the particle example is given 9 mega electron volt per c square, so if this particle convert into energy, it will release 9 mega electron volt. So what is the mass in mega electron volt per c square? This will give us a simple answer of how much energy is released or equivalent to energy released when this mass will convert into energy. That's why in terms of particle interaction, because the particles can annihilate and they can convert into energy, so it will be easy to get the answer and to know how much energy is released. Is it clear, the concept of annihilation?
Yes.
Okay. So copy this, pair annihilation or annihilation. And write this formula as well, E is equals to mc square. And the unit of mass can be in kilogram, but other units are mega electron volt or giga electron volt per c square. So sometime you have to convert the mass into kilogram if the mass is given in giga electron volt. So how you'll convert this mass? So or if it is given 9, example 9 giga electron volt per c square. This is a mass given and they say what is the mass in kilogram? So how to find this mass into kilogram? Because the SI, you have this formula E is equals to mc square. So means we need the unit of energy joules and we need the speed as meter per second. So when we have speed in meter per second and energy in joules, so when we solve, we'll get the mass in kilogram. So as we discussed that if mass is given 9 giga electron volt, so it means how many joules it will, how much energy it will release. It will release the energy of 9 giga electron volt. So 9 this giga electron volt, when we convert first into electron volt, so it will, giga means 10 power 9. So it will be 9 exponent 9 electron volt. But this electron volt we have to convert into joules. So how to convert this electron volt into joules? So as we know, 1 electron volt is equals to 1.6 exponent minus 19 joules. So this 9 exponent 9 electron volt will be equal to x joules. Cross multiply. So basically to convert electron volt into joules, I'll multiply by 1.6 exponent minus 19. So 9 exponent 9 multiplied by 1.6 exponent minus 19. What is the answer? When you multiply this?
1.44.
1.44?
Times 10 power minus 9.
So 1.44 10 power minus 9 joules. So means we have the energy in joules. Clear? But we need a mass in kilograms. So how to get the mass? Mass is equals to energy divided by c square. So we have energy in joules, which is 1.44 exponent minus 9. And what is c? C in meter per second, it is the speed of a light, which is 3 exponent 8. So what we will do, will 1.44 exponent minus 9 divided by 3 exponent 8 square. Why? Because this is the speed of a light square, so that's why 3 exponent 8 square. So energy in joules and the speed of a light which is there in square, so you can simply find the mass in kilogram. Is it clear, this example?
Yes.
Then opposite of annihilation is called a pair production. What happened when the part, because as we know the concept given by the Einstein that mass can be changed into energy or energy can be changed into mass, and they are related by formula E is equals to mc square. So when mass is changing into energy, what we call that as annihilation. But when energy is changing into mass, what we call that as a pair production. Why specifically we call pair production? Because when energy is changing into mass, like you have photons. So when photon interact, so what it will produce, or this energy particle or photon is there. So what it will produce two things. It will produce particle and antiparticle. So if electron is there, then it will produce positron. Both will move in opposite direction. Why they both move in opposite direction? To conserve the momentum. So a particle and antiparticle can be produced by a high energy photon or by collision between the other particles as well. So photon must have a sufficient energy to create a rest mass equal to the two particles. Like the energy which photon is having must be equivalent to the sum of the masses of the two particles so that it can produce particle and antiparticle. So example, the rest mass of a proton is 940 mega electron volt per c square. The rest energy of a photon means it's a similar idea, because what is the energy if it is 940 mega electron volt? So rest mass will be mega electron volt per c square. So photon produce proton and antiproton. So what should be the energy of this photon? Because it is producing particle and antiparticle. So as it produces particle and antiparticle, so if the rest mass for this is 940 mega electron volt per c square, and for antiproton is also 940 mega electron volt per c square. So how much energy this photon carry, which is responsible for this production or pair production? It should be sum of the rest masses of individual particle and antiparticle. So it will be 1880 mega electron volt. So this energy will change into mass, and we call this as pair production. Is it clear, the concept of pair production?
Yeah.
But practically it should be more than that. This is because what happened when this energy convert into mass, so particle will produce, but the particle should have energy to move as well. So that's why practically the energy of a photon should be higher than actual masses of the particles, the sum of the mass of two particles which are produced. Copy this, pair production. Only this part is